So hello everyone. Good afternoon. Good afternoon. Good afternoon to all. Can you hear me, students? Can you hear me? Am I visible and audible to all of you? Okay. Thank you, Bhavna and Anvisha. Thank you so much. So let's wait for 1 more minute so that other students can join quickly. So we'll start the class within a minute, okay? Yes, guys, you can see my screen, right? Is my screen visible to all of you? Yes, thank you. Thank you, Deepika. So yes, let's start the class now. So we are dealing with general organic chemistry, right? And till yesterday, we have discussed about the nomenclature part for hydrocarbons, that is for unbranched system as well as for branched system, right? So today, as I have told you, we are going to discuss the nomenclature of compounds with one functional group first, and then we'll move on to the system which has more than one functional group. Okay. So coming to the functional groups. So who are the functional groups? The reactive part of the molecule is called as the functional group, right? So I have given you the list of functional groups here on the screen. So we do have some 10 to 12 functional group, very important functional groups, which we use in our organic chemistry. And you can see there are 4 columns. The first is about the class of compounds. Next is the formula of that functional group. Then prefix and suffix of the functional group. Okay. So for carboxylic acid, the formula is COOH. Prefix you can see it is carboxy and the suffix is oic acid. And for esters, it is COOR, alkoxy carbonyl, and O8 is the suffix. For acyl halides, COH. So all these are carbonyl compounds. Carbonyl in the sense C double bond O containing compounds. Okay. So here it is COOR, and acid halides have CO, X, and who is this X? X is the halogen. Who are halogens? It can be fluorine, chlorine, bromine, or iodine. Okay. And the prefixes halocarbonyl and suffixes oil. And coming to amides, the formula for amide is RCONH2. And if these hydrogens are replaced by alkyl groups, you will have secondary and tertiary amides. Okay. So this is the functional group of amide, and the prefix for amide is carbomoyl and the suffix is amide. Got it? So these are the 4 important functional groups, and following these functional groups, we do have some other also. Just take a note of it so quickly. I'll go with the 5th functional group. Yes. So the 5th functional group is aldehydes, and the formula for aldehyde, as you can see, is it is C double bond OH. Prefix is oxo or formyl, and the suffix is Al. Since aldehyde starts with Al, it has to be end with Al. Okay. And for ketone, you can see it is RC double bond OR. R are alkyl groups. R are alkyl groups. So they will get substituted here. In all these places, the R groups, alkyl groups will get substituted. And the prefix for ketones are oxo and suffix is on. Since ketones ends with ONE, the suffix here is on. And for nitriles, it is CN is the group. That is RCN. Okay, RCN, and prefix is cyano. It is cyano and the suffix is nitrile. Okay. And for amine, we have three different types of amine. So the first one, which you can see here, RNH2, it is primary amine. And if you have only NH, it is secondary amine. And the R3N is tertiary amine. For all the three types of amines, the prefix is amino and the suffix is amine. Okay. And for alcohols, the formula is OH and prefix is hydro, prefix is OL. Since alcohol ends with OL, the suffix we use here is OL. Okay. And sulfonic acid. The formula for sulfonic acid is SO3H, prefix is sulfo, and suffix is sulfonic acid itself. And the next compound is nitro. The formula is NO2, prefix is nitro, and there is no suffix. There is no suffix for nitro. Got it? So clear for all of you? Did you all take the note of it? Shall I go with this slide? So if any of you want me to go with the previous slide, you can put it in the chat box. I will show you the previous slide. Okay. And the next functional group is alkane. As you all know, the functional group is carbon-carbon single bond here. So saturated hydrocarbon it is, and there is no prefix, only suffix, that is ANE. And coming to alkenes, they are a double bonded system, carbon-carbon double bonded system, no prefix and suffix is ENE. And coming to alkyne, they are carbon-carbon triple bonded system with two R groups attached to it. Again, the suffix is YNE, there is no prefix. And coming to halides, they are represented by the letter X. Fluorine, chlorine, bromine, iodine are the halogens, which are 17th group elements in our periodic table. And the prefix is halo. Halo means chloro, fluoro, bromo, iodo. Like that you have to use. Okay, so there is no suffix. So where do we use prefix and where do we use suffix? So if a compound contains only one functional group, then you have to use only the suffix. If the compound contains two functional groups, then the one which comes in the first priority, no, if for example, I'll take a compound, okay? I'll take a compound like this, CH3, CH, OH, CH2, CO. This is a compound. And in this compound, we have two functional group. One is carboxylic acid and the other one is alcohol. So in the priority order, I'll show you the priority list later, okay? So in that priority order, carboxylic acid comes first. So it takes the first priority. So what I have to do, I'll number the chain like 1, 2, 3, 4 like this. And for the group which has the first priority, for that particular system, I have to use the suffix. So what is the suffix for carboxylic acid? It is oic acid, right? So this I have to use. Since we have 4 carbon, it is butanoic acid. And the one which is in the second priority, for them, we have to use the prefix. So what is the prefix for OH? It is hydroxy. The prefix for OH is hydroxy and the suffix for OH is OL, right? Since OH comes in the second priority here in this compound, we are using the prefix of it. Got it? Clear, students? So how many functional groups we have seen? So carboxylic acid. So this particular order itself is the priority order for functional group. Okay. So 1, 2, 3, 4 and here 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, and 15. So alkene is coming in the first preference, then to alkynes. We have to make a note of it. So double bonded system should get the first preference and then only triple bonded system will come. Okay. So these are some of the functional groups and its prefix and suffix. So now let's try to apply these things in the compound. Let us take some examples and let's follow some rule to name the compound which has functional group. Okay. So the first step to name the compound is you have to identify the functional group in the compound. You have to identify the functional group in the compound. So can you identify the name of the functional group present here in the compound, which you can see on the screen? What is the name of the functional group here? Students, tell me what is the name of the functional group? We have 5-carbon hydrocarbon containing parent chain with one OH. What is the name of this OH group? It's alcohol, right? Yes, Bhavana, it is alcohol, right? So first we identified the functional group that it is alcohol. Yeah, good. OH is the functional group. It is an alcohol. So I told you for the system or for the compound which has only one functional group, okay, for that particular system, you have to use the suffix. No prefix will be used here. So what is the suffix for alcohol? It is OL, right? So we have identified the functional group and we have identified the suffix also. Now next what we have to do? Now you start numbering the longest chain. Start numbering the longest chain which has more number of carbons and assign the lowest number to the carbon possessing functional group. Means assigning lowest number to the functional group means you have to give the first preference or the first priority for the carbon which is attached to the functional group. Okay. So there are two different ways of numbering, right? We can go from left to right or right to left. So here we are using right to left system. Why? Because OH has to be attached to the carbon which has the very least number. Means the first priority. Okay, OH attached carbon should be given the first priority. So that's why here left to right to left numbering is followed. Got it? So this is the second step that you have to follow. And the OH should get the lowest possible number, that is 2 here in this compound. If you number here in this way, OH is getting the fourth priority. OH is getting the fourth priority number. So that is not acceptable. So the least value should be given. That is the first preference has to be given for OH attached to carbon. Okay. So the first way of numbering is correct and the second way of numbering is incorrect. Got it? Any doubt so far? If you have any doubt, put it in the chat box. Shall I go with the next slide? So what is the first step? First, we have to identify the functional group. And secondly, we are numbering the chain, longest chain, which has that OH. And the first preference is given to the OH containing carbon. Okay. Now coming to the third rule, you have to assign a root word. Third rule is assigning the root word. So who are root words? Methane, methane, prop, but, pent, hex. Those are the root words, right? So you have to see in the parent chain or in the longest chain, in this compound, we have 5 carbons. So what is the root word for 5 carbon containing system? Tell me the root word for 5 carbon containing system. Yes, good Rashmi. It is pent. So now what we have to do? We have got that the root word is pent. Very good, Bharat. Good. Root word is pent. And since the whole compound contains only single bond, the suffixes, the primary suffix is "ene" because it is alkane. And we have assigned primary suffix. And now coming to step 5, you have to assign secondary suffix. Secondary suffix are the functional groups. It is alcohol. The suffix for alcohol is OL. The suffix for alcohol is OL. Very good, Anvisha. It is OL. Yes. Now what is the sixth step? You have assigned the secondary suffix OL and the position of the functional group is 2. Position of the functional group is 2. Now what is the name of this compound? You have to replace the E by OL. You have to replace the E by OL to name the compound. So it becomes pentane. Pentane is the actual name. And in pentane, you have to remove this E and substitute it by OL. And before substituting like this, what you have to do? You have to define the position of the functional group to which the carbon is attached. No, so OH is attached to the second carbon, so it is pentane 2 all. Pentane 2 all. So this is how we are naming the functional group, naming the compound which has only one functional group. Got it? Any doubt? If you have any doubt, just raise your hand and ask your doubt. I'll explain it again. No prefix. There are no prefix for this compound. No prefix, only suffix. Since it has only one functional group, only the suffixes will be there and the root word will be there. No primary prefix and secondary prefixes are used here. Okay? Clear for all? Shall I go with the next slide? If it is clear, put yes in the chat box. We will move on. Yes. Thank you. So there is another compound to all of you. So what is the root word? Can anyone find out the name of this compound? Yes, thank you. Thank you so much to all of you. Can anyone find out the name of this compound? Can anyone? So the root word is hex because we have 6 carbon, right? So 1, 2, 3, 4, 5 and 6. So the root word is hex. And how many functional groups we are having here? The main functional group is COOH. What is this? This is the carboxylic acid. This is the hexanoic acid, Rashmi. Yeah, you are partially correct, but you have to give the position and you have to define the double bond and triple bond also, right? Hex is the root word and I have numbered from right to left. Why I have numbered from right to left? Because the COOH has to be given the first priority. That's why. Okay. Now this double bond and triple bond, they are getting the second preference. Double bond suffix is "ene" and triple bond suffix is "ine", YNE. These are the primary suffix. Okay. Now the secondary suffix is oic acid because the class of compound COOH is carboxylic acid. For carboxylic acids, the suffixes are suffix is oic acid, right? That we are doing, and the numbering is also done. As you can see on the screen, the numbering is also done from right to left. And what is the position of the functional group? It is 1. Now, one more thing you have to know. So, if the functional group contains carbon, then you have to number that carbon also. Because the numbering is only for carbon, not for heteroatoms. Okay. So in the last example, we had OH group attached to a carbon. So we did not number this oxygen. Because numbering should not be given for oxygen, sulfur, etc. Numbering is only for carbon. So if your functional group contains carbon, you have to number that carbon also. Okay. Suppose in case of CHO also contains carbon, so you have to number this carbon. And if your compound contains CN, you have to number this carbon. Now, if your compound contains NH2, will you number this nitrogen? No. Yes, Lakshmi, tell me. Yes, Lakshmi, you have raised your hand. You have any doubt? If you have any doubt, let me know in the chat box. No doubt? Okay. Okay, students, tell me, if a compound contains NH2, will you number that nitrogen? Will you number this nitrogen? Yes or no? No. Yeah, because it is nitrogen, right? Good. We should not number the nitrogen. So you have to number only the functional group which has carbon in it. So that's why we are numbering this carboxylic acid carbon. And we are getting 6 carbon here. So the IUPAC name should be, the root word is hex. And between double bond and triple bond, Double bond should come first, right? As I have told you while discussing the functional groups in the list, I told you double bond should be given the first preference. So 2 ene, and in this ene, the E is getting replaced by Y and E. To which carbon this Y and E is attached? It is between carbon number 4 and carbon number 5, right? So you have to take 4. You have to take the lowest number to which the double bond or the triple bond is attached. And between this C, double bond C, it is between carbon number 2 and 3. You have to take 2. That is the lowest number. And triple bond is attached between carbon number 4 and 5. So here the lowest number is 4. So that's why E is getting replaced by 4 ine. It should be 4 ine. And also we have functional group. So again this E is getting replaced by oic acid. So the name becomes hex-2ene 4-ine oic acid. Okay. Hex-2ene and 4-ine oic acid. This is the name of the compound. If you do not have COOH attached to the system, and the compound is like this. If you have the compound like this, what is the name of the compound? Let me complete the compound first. Yeah. If this is the compound, what is the name? Can you find the name of this compound? How will you number this compound from left to right or right to left? From right to left, right? Because double bond should be given the first preference. So 1, 2, 3, 4, 5, 6. Has anyone got the answer for this compound? The IUPAC name? So what is the root word, students? Root word is hex, right? It is hex. Now between carbon 2 and 3, we have double bond. So it is hex. 2-ene. 2-ene will be there. And now between 4 and 5, we have triple bond, right? So this ene is replaced by 4-ine. That's all. Got it? Hex-2-ene and 4-ine is the name of this particular compound. None of you get the answer? Fine. Any doubt here in this compound? Any of you have any doubt? Ene comes before ine in the name. No matter what the locants are. Ene has to come before the ine. Okay. Shall we go with the next slide? Yeah. So now next we are. Thank you so much, dear. So the next topic is the nomenclature of compounds with more than one functional group. Okay. Okay, let's see. So a compound is given to you on the screen. Now, first of all, I'm telling you that the compound contains 2 functional groups. Now, first of all, you guys tell me the name of those 2 functional groups which is present here in this compound. Let me see who is giving the correct functional groups present in this compound. So what are the 2 functional groups present here in this compound? Very good, Rashmi. Ketone and carboxylic acid, right? So what is the general formula for ketone? It is R, C double bond O, R. I told you R are alkyl groups. So this is your R and this is CO and this is your R group. Okay. So here is the ketone. This is your ketonic part and this is the carboxylic acid part. Okay, good. One among you have given the answer for this. Now, what is the next step, students? What is the next step? We have to start numbering. What we have to do, the ketone and carboxylic acids are present. Good, Charan, good. Yeah. So ketone and carboxylic acids are present here. And now you have to check for the group which is coming in the first priority. So here the carboxylic acid is the main functional group which has the first preference. Yeah, Vidyashri, you are correct. So to know the priority order, you can take a screenshot of this slide. to know the priority order. The one which has to get the first preference can be taken first. Carboxylic acid always get first preference, then sulfonic acid, esters, acyl halides, amides, nitriles, aldehydes, ketones, alcohols, solvents, alkene and alkyne. So these are the very, very important functional groups among a very big list of functional group which follows the priority order. Okay. So what you have to do? All of you have to memorize this priority list. There is no other way, right? You have to memorize this list. The name of the compound and the functional group. Okay. So in the last given compound, COOH and what else we had? Yeah, keto. So these two functional groups were present in the previous compound. Now COOH has to be given the first priority. So did you all take the screenshot of it? Shall we go with the next one? Yes. Okay. Yeah. Okay. So now the ketone is getting the lower priority. So the one which is getting the lower priority acts as a substituent. Okay. The one which is in the lowest priority has to be given the prefix. And the one which is in the higher priority is the main functional group for the given molecule. Okay. So we have to number from carboxylic acid. So we are getting from 1 till 6. There are 6 carbon containing system. And this is the functional group. So for this, you have to use oic acid. That is the suffix you have to use. Oic acid is the suffix. And ketone is the second priority substituent, right? So what is the prefix for ketone? Do any of you remember the prefix for ketone? While starting the class, we had own. No, own is the suffix for ketone. What is the prefix for ketone? Prefix. Now ketone is acting as a substituent. No, N is not the answer. N is not the answer. Very good, Anvesha. Yeah, Meenakshi, you are also correct. So it is oxo. The prefix for ketone is oxo. No, E, no, not E. So you guys have to memorize the list which I have showed you in the while starting the class. That is the prefix suffix list and the priority list. Okay. Oxo is the prefix for ketone. Not keto, it is oxo. Okay. Now this particular substituent, which is ketone, is in the 5th position. So what you have to do? It is 5-oxo. It is 5-oxo. And there are only 6 single carbon here. There are 6 carbon containing single bonded system. So it is, the root word will be hex and it is alkane. So it is hexane. It is hexane. And from hexane, what you have to do? You have to replace, very good Lakshmi, you have to replace this E by oic acid. You have to replace the E by oic acid. Okay, so what is the name? 5-oxo hexanoic acid. Good. It is not the 4-oxo with Yushti, it is 5-oxo only. So in the 5th position only we are having the ketonic carbon, no? In the 5th carbon, only the ketonic carbon is there. That's why it is 5-oxo. 5-oxo. Numbering is for carbon and the name is for oxygen. So to the 5th carbon only oxygen is attached. So it is 5-oxo. Got it? Since the ketone group has carbon in it, we are numbering that carbon also. Clear, Vidyashri? Fine. So 5-oxo hexanoic acid. Yes, okay. Okay. So there is one more compound to all of you. So who is going to give me the name of this compound? I'll give you 30 seconds. I'll give you all 30 seconds. Try to get the name of this compound and put it in the chat box. Let's see who is getting the correct answer. 1,2-diethyl, 1,2-diethanol. You are all coming closer to the answer, but it is not the correct answer. So in IUPAC naming, there should not be any change. The name has to be given as such. Okay, you have to follow all rules. So in this particular compound, how many types of functional groups we have? How many types of functional groups we have? Types of functional. Only one. That is alcohol. That is alcohol, right? Only one functional group means what we have to do? We have to start from the root word, right? Only if you are having two different functional group, you have to give prefix, then only you have to come to the root word. If you're having only one type of functional group, then start the name with the root word. So how will you find out the root word? From the number of carbons. So how many carbons are here? Only 2 carbons. You can number from left to right or right to left, no problem, because only 2 carbons are there. From left to right also 1 and 2, right to left also 1 and 2. Right? Now here only is a saturated system, so it is an alkane. 2 alcohol we are having, so it is diol. It is diol. Now what is the name? Name has to be written from the root word. So ethane, since we are having 2 carbon, it is ethane. Ethane is the root word. And since we are having 2 alcohol, it is written as diol. This is the suffix. And the alcohol's position also has to be given. So in the first and second carbon, 2 OH are attached. So ethane 1,2 diol. Ethane 1,2 diol. Clear for all? Clear? Ethane 1,2 diol is the correct answer. Yes. Good. So don't go with the prefix if you're having one type of functional group. Okay. Start with the root word. Fine. One more compound. One more compound to all of you. Here, how many types of functional groups we have? 1 or 2? 1 or 2? 2. What are those 2? What are those 2? Anvisha, 1 we are having? No, we are having 2. So we have 2. What are those 2? Ketone and alcohol. Yes, very good. Ketone and alcohol. Now you see, the numbering is from left to right. Very good, Bharat. It is ketone and alcohol. 2-oxo-hept-7 or? No. You see the preference? From left to right we are giving. So in that priority list, you have to see. So let me go with the priority list. In priority list, what is the order we have studied? So see the priority list. So ketone is here and alcohol is here. So who has to be given the first preference? Ketones, right? So ketone has to be numbered first. So ketone should get the first preference. So that's why we are going from left to right here in this compound. Okay. Now, this alcohol, this OH is the substituent. OH is the substituent. If it is a substituent, what you have to do? If it is a substituent, you have to use prefix. So what is the prefix for OH? It is hydroxy. The prefix for OH is hydroxy. Okay. Now we have a prefix. We have to start the name with the prefix because the skeletal structure of IUPAC name is prefix plus root word plus suffix, right? This is the skeletal structure. Now, since I have prefix, I have to go with this. So this particular prefix hydroxy is attached to the seventh carbon. So what is the name? It is 7-hydroxy. 7-hydroxy. So prefix got over. Then root word, right? Root word. What is the root word? 7 carbons are there in the parent chain. So what is the root word? It is heptane. It is heptane, right? Now we have ketone group here. Ketone is the main functional group. So if ketone is the main functional group, you have to use suffix. So what is the suffix for ketone? It is ONE. So you have to replace this E by ONE. You have to replace this E by O-N-E. So that particular ketone is attached to the second carbon. Ketone is with the carbon number 2. So it is 7-hydroxy-heptane 2-one. Even if you write heptanone, it is also correct. Even if you write heptanone, it is also correct. Because ketone cannot be in the first position, right? In both the sides, we are having R group, right? So always ketone will be in the second position only. So even if you don't write number 2 there, no problem. You can write 7-hydroxyheptanone. That is also correct. But if it is in the third position or fourth position, obviously you have to mention 7-hydroxyheptane 3-one, 7-hydroxyheptane 4-one, like that you have to mention. For 2 only, there is an option. You can write or you cannot write. Don't want to write. Clear for all? Any doubt here in this compound? Shall we move on with the next compound? Next slide. So basically, you are all going to memorize the 2 tabular columns. One is priority table and the prefix suffix table for functional groups. Okay. So heptane 3-one. 2-oxoheptane 7-ol is wrong. Why this naming is wrong? Because in the priority list, alcohol will be in the second position. So it is the suffix. That's why it is wrong. The alkyls, halogens, nitro, alkoxy, all these compounds are always prefix substituents. Always prefix. Fluoro, chloro, bromo. In case of R group, methyl, ethyl, propyl, and phenyl, nitro, alkoxy. Alkoxy means you can have OCH3, methoxy, ethoxy. So those are your prefix substituents mainly. They will not be the main functional group. Okay. So who are the substituents? Who are the prefix substituents? They are alkyl, alkoxy, mostly halogens, and phenyl and nitro. So these are the substituents. So the general name for all these substituents are for R, it is alkyl, methyl, ethyl, propyl, and this is alkoxy, and this is your halo, like fluoro, chloro, bromo, iodo, and NO2 is your nitro. And if you're having C6H5, C6H5 is phenyl. This phenyl. So from benzene, if you remove one hydrogen, you will get phenyl group. Okay. So these are the prefix substituents mainly. So yes. So there is a question. You have to find out the IUPAC name of all the 4 compounds given in the question. So this is an exercise to you. Can anyone give me the name of the first compound within 15 seconds? Name of the first compound within 15 seconds. Okay, let me see whether anybody is giving. Otherwise, we will discuss. Try for the name for the first compound. Okay. So take the compound A. And what is the first 2-bromo, 2-chloroheptane? Heptane is correct. But once again, you check the number of the, yeah, good. Correct. It is 3-bromo. Okay, no problem. No problem with Yashvi. Yeah, Rashmi is correct now. 3-bromo, 3-chloroheptane. So we have to find out the parent chain. Very good, Bharat. So the parent chain is this. So what is the parent chain? Longest carbon containing chain. So this is the parent chain. We got that. Then what is the next step? We have to start numbering, right? So from left to right, we have to number. Because from right to left, if you come, you will get 1, 2, 3, 4, 5. No, that is not correct. Yesterday we have discussed that the substituents should get the lowest possible number. That is the first priority, right? So the left to right numbering is correct. And you can see 2 substituents attached to carbon number 3. One is chloro, the other one is bromo. So now we have to go with the alphabetical order. So B comes first. So it is 3-bromo, 3-bromo, 3-chloroheptane, 3-methylpentane, 1-nitrile. Okay, I'll come to that. You guys are so enthusiastic, na? Very good, That's great. So let's check. So the name of the second compound is 3-methylpentane nitrile. 3-methylpentane nitrile. So how they have numbered? From left to right or right to left? From left to right or right to left? Right to left. Because cyanide is the functional group and it has to be given the first priority. So 1, 2, 3, 4, 5. Okay. And to the third carbon, we have one methyl group. This is the methyl group, which is a substituent. So 3-methyl. So this is the prefix 3-methyl. And next is the root word. Root word is pentane, since it has 5 carbon. And now the suffix for CN is nitrile, right? Since it is attached with the first carbon, it is not given the number here. You can just write as it is, pentane nitrile. And the name of the third compound is 3-chloropropanol. It is 3-chloropropanol. So what is the name of the functional group? This is COH. What is CHO? CHO is aldehyde. It is aldehyde. Now you have to start numbering from aldehydes. Since it is the functional group and chloro is the substituent. It is a halogen derivative. Halogen, no. 2-chloro. Check once again. So this carbon is numbered 1. This is 2 and this is 3. So to the third carbon only, chlorine is attached. So it is 3-chloro. 3-chloro is the prefix and the root word is prop. Since we have 3 carbon in the parent chain, it is root word. And in propane, what you have to do? You have to replace the E by Al, right? E by Al, because the suffix for aldehyde is Al. Oh, that is for answer D. Okay, I'll come to that. The answer for compound C is 3-chloropropanol. Then coming to option, compound D. So let me expand this. It is CH, CH2, OH, and to this carbon, 2 chlorines are attached. Now, how will you number? From the OH attached carbon only, we have to start the numbering because that is a functional group. So 1 and 2. So now to the second carbon, we have 2 chlorine, right? So what you have to do? 2-chloroethanol, 2-dichloroethanol, both are wrong. Check for the correct answer. What is the correct answer? To the second carbon, 2 chlorines are attached. Very good. 2,2 dichloroethanol. This 2,2 dichloroethanol. Good Vidyashree. Good. So, very good all of you. Yes. Yes, JNV, KSD, music. You can change your ID, no? So that I can come to know your name. Okay, fine. So, good. Good students. So we'll move on to the next topic, that is the nomenclature of aromatic compounds. So any doubt for any of you in the nomenclature of functional group containing systems? No. Okay. So try for more compounds from your workbooks, and if you are getting any doubt, you can ask me. Okay, I'll clear for you. Now coming to the nomenclature of aromatic compounds. So the nomenclature of substituted benzene compounds we are going to see, which are nothing but the aromatic compounds. My name is Veena. Okay. Because in the ID it is coming as Vidyashree, that's why I'm calling you Vidyashree. Okay. I'll call you Veena hereafter. So moving on to the lesson. The substituent is placed as prefix to the word benzene. What is the formula for benzene? It is C6H6. So substituent is placed as prefix. So to the benzene, here you can see one CH3 is attached. So what is the name of that CH3? It is methyl group. CH3 is methyl. So the name of this compound is methyl benzene. So the substituent methyl is placed as prefix to the word benzene. And the other name for this methyl benzene is toluene. Okay, the other name for methyl is, we are the students of JNV Kasargod. Oh, okay. So from a single ID, more number of students are there from us watching from a single ID. Okay. So just a second. Yeah. Sorry for the interruption. 40 students are watching. Okay. Good. No issues. So I thought that only one person is watching from that area. Okay, no problem. Good. Yes. So the substituent is placed as prefix. The other name for methyl benzene is toluene. And you see here, so here OCH3. What is the name of OCH3? It is an alkoxy, right? With the alkyl, when oxygen is there. So it is alkoxy. Since the alkyl group is methyl, it is called as methoxy. That is a substituent. It is methoxybenzene. The other name for methoxybenzene is anisole. And here you see amine group. NH2 is the amine group. So it is aminobenzene, which is otherwise called as aniline. And this is the aldehyde group. Aldehyde CHO is not the prefix, right? This is not the substituent actually. This is the main functional group. So you should not put it in the suffix. So you have to end it with the suffix. So it is benzaldehyde. And this is NO2, which is nitro substituent. So nitrobenzene and bromobenzene. And here is again the functional group. The main, very important, the first preference functional group. No, so it is benzoic acid. And one more thing is there, which is called as phenol. If the benzene, if the phenyl ring contains OH attached to it, it is called as phenol. So these are the substituted benzene compounds which are very, very important for your organic chemistry lessons. Okay. Suppose in your class 12, you are having haloalkanes and haloarenes lesson. In that lesson, this particular compound will be discussed. And you have alcohol, phenol, and ether. So in alcohol's lesson, in alcohol phenol, this compound phenol will come, and in ether, this part will come. This anisole is an ether. Okay. In case of amines lesson, aniline will be discussed. In aldehydes, benzaldehyde will be discussed. In carboxylic acid, benzoic acid will be discussed. Okay. So in hydrocarbons, next lesson, methyl benzene will be discussed. So in each lesson, the corresponding functional group containing aromatic compounds will be discussed. So you have to know the names of all the benzene substituted compounds. Okay. Clear? So coming to the aromatic system, which has more than one substituent attached to it in the ring. So here in this compound, you can see that there are two groups attached. Both are same here. Both the substituents are same, which is bromo. And now how to name this? If more than one substituents are attached, then you have to name the number the carbons to which the substituents are attached. Now how will you number? I'll do from clockwise direction first. So 1, 2, 3, 4, 5, 6. Okay. Now if I am going from anti-clockwise direction, then also I'll get the same number. If I'm going from anti-clockwise, I will number from here 1, 2, 3 only. So again, number 1 and 3 will come to the carbon which bears that bromo substituent. So no problem. You can go from either of the ways. So here, let's take the clockwise manner. Lowest numbers has to be given to the substituents. That's why the carbon which is attached with the substituent is getting the first preference. Okay. So what I'm trying to say is you should not just number from 1, 2, 3, 4 like this. Okay. If you number like this, the bromine containing carbon will have 2 and 4. So it is wrong. 1,3-dibromocyclobenzene. No, you have to cut one part from your name. If you cut that part, the name is correct. Okay. So we are going from the system which carries the substituent. So starting from bromine containing carbon. So 1 plus 3 is 4, which is the lowest number, and it is called as 1,3-dibromobenzene. Very good, Rashmi. It is 1,3-dibromobenzene. So which word we have to cut? We have to cut that cyclo. So cyclo should not be given. So where we use cyclo, we use that in case of your alicyclic system. Alicyclic means if the carbon, yes, good. If the system has only the cyclohexane ring and if two Br are attached like this, then your name is correct. In that name also benzene should not be given. So the name of this compound is 1,3-dibromocyclohexane. 1,3-dibromocyclohexane is the name of this particular compound. Got it? So this is aliphatic compound and this is your aromatic compound. This is your aromatic compound. So it is 1,3-dibromobenzene. So this part is your prefix. This part is your prefix and benzene is the root word kind of. So this is correct. This is correct. So this numbering is wrong. Why it is wrong? Because we are having 1 plus 5 is 6. It is not following the locant rule. So 1,5-dibromobenzene is wrong. You should not number like this. It is not the lowest number. Okay. Yeah. Coming to the next part. So in trivial system, what is meant by trivial? In common name, we have two different types of naming, no? Common and IUPAC. So in common name, the term ortho, meta, para are used. So what is ortho? Ortho means adjacent. What is ortho? Adjacent. So what is the common name for this 1,2-dibromobenzene? It is ortho-dibromobenzene. O-dibromobenzene. Okay. And this is 1,3-dibromobenzene, which we have discussed. Now this is called as meta-dibromobenzene. Yeah, Vidyashri, good. Now if two bromines are opposite, 1,4-dibromobenzene is the IUPAC name and para-dibromobenzene is the common name. So ortho means adjacent. You can see two groups are adjacent to each other, and meta means it is alternative. It is alternative, and para denotes opposite. Para denotes the opposite. So adjacent, alternative, and opposite. So these things we are using in the common name. So this is the common name list, common name, and these are your IUPAC. Okay. So that's all about the substituted benzene compounds, di-substituted compounds. So first we have seen the monosubstituted compound, that anisole, aniline, those things we have discussed. No, those are monosubstituted and these are di-substituted. And now I'm moving to tri-substituted. Okay, tri-substituted. So in some cases, the common name of benzene derivatives is taken as the base of the compound. It's taken as base of the compound. So the IUPAC name of this particular compound is 1-chloro-2,4-dinitrobenzene. So why it is named like this? Why it is named like this? Because only if I start from chloro, I'll get 1, 2, and 4. If I start from nitro, if I'm starting from nitro, I'll get 1, 2, 3, 4, 5, 6, right? So you see, The nitro containing carbon gets 1 here, and here it is 3, and here it is 6. So 1 plus 3 plus 6 is 10. Okay. Or if I am starting from this particular nitro and coming in the clockwise direction, 1, 2, 3, 4, 5, 6, what I'm getting? 1 plus 4 plus 5, right? What is 1 plus 4 plus 5? Again, it is 10. Okay. So only if I start from chloro, I'm having 1, 2, 4. What is 1 plus 2 plus 4? 7, which is the lowest number. So low control we have to use, right? Yes, Bharat. Yes. So that's why it is numbered like this. And for naming the compound, I have to take C first because it is chloro and these two are nitro. So in alphabetical order, C comes first. So it is 1 chloro, 2, 4 dinitrobenzene. And you can see this compound also. Only this way of numbering from bottom to top gives you the lowest possible combination. So it is numbered like this. Now this is methyl. Here is your chloro. And here is your nitro. So it is alphabetical order means it is C comes first. So 2 chloro, 4 nitro, toluene. We have seen, right? The benzene ring with CH3. It is called as methyl benzene or toluene. The mono substituted slide I have shown you. So this whole part is taken as toluene. So 2 chloro, 4 nitro, toluene is the name of this compound. Any doubt? Any doubt? No doubt. So practice all the compounds. So in the next class, we can see the isomerism. So we have completed all the nomenclature part, all the common name, IUPAC, for mono, di, tri substituted benzene, for aromatic, aliphatic, for everything we have did. Okay. So try solving the questions from this. Thank you so much, dear students, for listening the class. So meet you all in the next class. Okay. So meet you all in the next class on Monday. Thank you. Thank you. Bye-bye. Yeah, bye-bye.